now see my screen, and yeah, as Marcus said, we're now jumping into this hands-on part of the tutorial. So essentially, we're just gonna open up a Jupyter notebook. I'm gonna tell you in a minute how to do this. But we're gonna open up a Jupyter notebook to like explore, like really from the very basics of how would you like first of all create a schema. So Marcus already talked a lot about schemas, and that structured data is very important in NOMAD. So we're gonna explore how you would actually design a schema and what kind of considerations you have to make there. We're going to look at how you would build a primitive parser and also how you would do data analysis. So we're going to go through like a lot of different things in this notebook. And yeah, it's basically all of the content will be accessed through Nomad. So we already have this Jupyter Hub environment available in our production deployment. So essentially, it's just if you have a computer, as you have because you're here, and you have a browser, and importantly a Nomad account, then you're going to be able to follow this tutorial on your own as I go through it. So now, really, the key part here is that we are going to use for this tutorial, we're going to use this our beta deployment because we have kind of prepared it for this tutorial. So please, if you could, I will just give you some time to go to nomad-lab.eu, and at the bottom of the page you will see this link to installations, and there's a beta/staging link. I will show you in a minute as well where you can find this. But the idea is that you go into this special deployment that we prepared for this tutorial. And now, if you already have a Nomad account, you just signing in there. So your existing account will work there as usual. If you don't have an account, you should just create one. And this is free, so it's very easy to do. Now, basically, I will give you a few minutes to do this. But this is what you'll need if you want to follow on your own and really like run the code on your machine and do some experiments. This is what I would suggest you to do. You can also just follow my screen and what I'm doing there, but I think you get much more out of this tutorial if you just really do the hands-on stuff. So yeah, we're gonna basically like start from the very basics. So it's gonna be really simple stuff, but we're gonna build on towards more advanced concepts. So the idea is that, yeah, just ask away when anything is unclear, and like let's keep it quite informal and make more of a discussion. So I'm just gonna like quickly show you where you can find these things. Maybe I can thing out of the way. So as I mentioned, let's use this beta deployment that we have. So if you go to this our main page, at the bottom you will see these installations. Yeah. So we are now in the main page, and at the bottom, yeah, you have this installation section, and here is the beta/staging link. So click there, and this will now redirect you to this deployment that we are interested in. And now, yeah, as I mentioned, I'll give you a bit of time. So either if you have an account, you just log in here, like I already have one. If you don't have one, you will just click here on the register button, and you can create an account in a minute. Basically, you'll need to fill in a few things in here if you don't have one. So username, passwords, and so on, pretty basic stuff. And then you register. You get a link to your email and you activate your account and you're done. So if you don't have an account, you can do this quite quickly now. I will give you a minute to do this. But yeah, if you already have an account, you can just sign in here. Okay, so while you are doing this, I'm just gonna like very briefly go over the next steps. So basically, once you have an account, you are signed in here, what we're gonna do now is that we're gonna basically go go to this publish menu, where you will have a section for uploads, and we are going to add a new example upload. So there's this link or a button here called Add Example Uploads, where we are gonna find a new tutorial. It's called NOMAD as a Data Management Framework tutorial. And in there you can press Add. I will show you this in a second as well on the website itself. And we're just gonna, basically, this will create a new upload on your account, and which contains the notebook that we wanna run, and we're gonna basically open it up directly on our Jupyter environment. And basically then we are ready to start. But as I mentioned, once you have logged in, you can go to Publish menu. Here you will see uploads. Well, I already have quite a bit of uploads here, but maybe if you're a new user, you don't have much, but this is the button that we are after. So Add Example Uploads. And in here, it's this, under this tutorial section, we have a tutorial called NOMAD as a Data Management Framework tutorial. And this is the one that we want to add. So press the Add button, and you will basically get this new upload in here. And we have basically two tabs here, and we can explore now the files that are included in this upload by pressing the Files tab in here. And you can see that there's a few files that have and folders that are prepared here already. The one that we are really interested in is this notebook. So there you can see that we have a Jupyter notebook in here, and we can now directly launch this notebook in Jupyter directly through the browser by clicking this. It takes a few seconds to launch it, but what you will get there is a new tab with this notebook opened in here, and basically this all is like enabled through our Jupyter Hub integration. So these notebooks, you can really put them inside your uploads, and they can mount data from your upload and work with it. So this is like the kind of functionality of NOMAD that we are now using in here in this tutorial. So now, if you now have any problems getting in here, once again, just write in the chat if you have any problems in opening up this notebook. I will give you a few minutes to do this, and then we will basically start. Once everybody is roughly at this stage, we will start out with the actual contents. So hopefully the steps are fairly clear. So basically add example upload. Once you have the upload, you go to the Files tab. There's a Jupyter notebook file in here, and you launch it in the Jupyter app, and then you will get in here. Basically, we're gonna start out with like taking a look at a kind of like a example data that we have prepared for this notebook. So you might want to run this first cell just to see that your notebook works and functions correctly. So this does a few things, prepares a few variables for you for the future. So you can run this first cell, and in general, it's kind of important to run now the cells in order for the tutorial to go smoothly. So remember that to run each cell sequentially. That's kind of important. We will skip this part because we are basically have already prepared everything in here. Let's just start with the data section. So basically, this tutorial is about like imagining a scenario where you have some raw data. In this case, we're working with this countries of the world data, but you could imagine that you have just some raw file coming from your experiment, some sort of like a measurement, or from a simulation. It could be anything. And now we just want to kind of explore how you would work with this like originally kind of unstructured data, and how you would start designing a schema around this data to kind of capture the information that you want. So the raw data that we are working with looks something like this. So it's like a regular text file which has some fields in there that now we want to somehow capture. And really the first thing that you want to do in NOMAD is that you want to write a schema around your data. And we can do it directly now here in the Jupyter environment. So we're going to use these concepts that Marcus already discussed about. So we basically have quantities, sections, and subsections, and with these you can do already quite a lot. And so we saw that the data that we want to capture is about countries. So we're going to start out by simply designing a schema for a country. And in Python, this is basically done by defining a new class called country that inherits from M section. So this is basically saying that now we want to describe something that is a country. And we're going to add, like, define new quantities in here. We want to first define the name of the country. So it's going to be a quantity of type string. And we also have a population, which is now an integer quantity. And we have an area, which is a floating point number. And it has also some unit. And this is like something to get you started. So basically we're now capturing a few of these raw data inputs with this schema. So now with some sort of like a data structure already in mind, we can now start populating this thing. So in the next cell, you can see that we can basically use this new country class and start populating it. So we're going to say that the name of this country is Germany. We can say that population is this and that. And we can also assign a new area for this country. And here you can start seeing some of the like automatization that is already built into these Python classes. So for example, this area already has been assigned a unit. So now you can basically assign just raw numbers to it, or you can assign something that is attached with a unit to it. And you can see that basically where we're using this unit registry, which contains like units for a lot of different things. So there's, in this case, there's square kilometers, and it understands miles and so on. So you can perform automatically these unit conversions by using these constructs. So you can see that because our area was defined in square kilometers, and now if we assign square miles into it, we can see that the output is gonna basically do this conversion for us automatically. So these are the kind of things that come through this automatized behavior from these quantity classes. And so this is kind of nice, and it's very important to like always keep the units in there and know in which units you are working with. And that's a very important part of this design, especially when working with like measurements and simulations. So this is like a big source of errors, is basically leaving out the units or ignoring them or not taking them into account to some. So this would be basically like how you could capture this data as it quite simply. But typically there's also other things, like more human related things that you want to add into these schemas. So you may have, for example, descriptions, which are very important to understand. Okay, what do I mean by name? What do I mean by population? So on. So you can attach descriptions into these quantities. And basically it's a human readable description that you can attach to any quantity. You can also attach links to, for example, to sections, to like link them to some resources. So this is kind of for humans to understand what you're talking about when you're designing the schema. And yeah, we are basically all of these units are handled with the Python library for those who are interested in this. So it's like a quite well-known library for handling these units. And we have basically defined like a custom unit registry which contains the units that you're interested typically in the condensed matter, but also a lot of units beyond just condensed matter things. So this would be like an example of a fairly simple schema for a country. But now let's go a bit deeper. So let's imagine we would want to capture some sort of like a time series, for example. So we're gonna now start like utilizing these sections and subsections that you can have for in this schema. So let's start like designing a new section called time series. And in there, we basically want to capture some sort of time series data for that, for example, capturing the GDP of a country for each year or the population and things like this. So we have a new class definition for time series, which has a year as a quantity, as an integer quantity. It has now, it's not a scalar anymore, but it has a shape. And essentially, we can say that the shape is basically, this means that it has one axis. So it's like a 1D vector. And the star basically means that it can be of any length. This basically the syntax, if you would just add in here another shape or another item in this list, you can make it into a 2D array. So typically when working with, for example, simulations, you will have these multi-dimensional arrays quite often. So it's just a matter of what kind of shape do you define for this. In this case, let's keep it as a 1D array. So we have the year and the value here. And now we're going to utilize this new class inside our country. So we're going to define new subsections for this country. And this allows us to capture now the GDP of the country as a time series and the birth rate. This is, as somebody's asking, basically, is it like NumPy syntax? So it's very close to what you would do in NumPy as well. So when in NumPy arrays, when you're defining like a shape, you basically give it that you have a shape of 3 by 3 or something like this. But so it's inspired by this, but in our case, basically we can also allow things like it has arbitrary shapes which like NumPy doesn't allow you to do, because you always have to give a concrete number. But in our case, when you're just designing these schemas, you can say that it can be of any length. So here is an example of how you would then define these subsections. So GDP is defined as a subsection, which is basically, it's a time series, and you can have attach a description once again for people to understand like what are you actually capturing with this. So this is the GDP per capita, and we have also the birth rate, so which is also of type time series, and this is per 1,000 people per year. So in this way, we've been able to like capture like this this hierarchy of things in this country schema. So you can have subsections, and these subsections themselves may have subsections. So it's you kind of get this hierarchical structure to your schema. And now, in order to let's do something with this. So we can basically start, for example, we could, for example, see what does this look like in another format. So if we now, like Marcus was also mentioning, that we have basically two ways of writing down these schemas. So you can either write them as Python classes, as we are doing here, but the other approach is to write them as YAML files as well. And basically you can translate this Python schema into a YAML equivalent quite easily. So it's basically a matter of wrapping it up in an entry archive and dumping it out into a dictionary, and this dictionary can be then serialized as a YAML file. And this is an example of if we take out just this country schema and we serialize it into YAML, this is basically what we're gonna get out. So it has exactly the same things as in the Python example. So you can see that there's the population, there's a name, it has these subsections that we defined. Basically, this birth rate and the GDP per capita in there. And it has the definition for this time series section as well. So everything is kind of captured in here as in YAML format. And this is something you could directly put into your upload without needing to write any code. So up to this point, you can do both of these things basically either in Python or in YAML. So it doesn't matter up to this point. What we're going to discuss next is where the differences come in. But this is basically the idea. And there's this concept of packages that you would need if you really want to start out like writing your own plugins, like schema plugins and things like this. But this like is a bit outside beyond the scope of what we're doing in here. But basically, if you now understand roughly the concept of what quantities are, so they really capture concrete pieces of data, so numbers, strings, and so on. And then there's sections which basically give some sort of hierarchy to your data. So with this, you can already get very, very far. So maybe let's just look at basically what then differentiates the YAML schema from the Python schema. So there's this, basically it boils down to this question, so why not just then write always YAML files? And basically the answer is that in Python, in addition to just describing the structure of your data, you can add functionality as well. So if you are designing your schema in Python, you can attach this. So basically you can have these sections defined as classes, and these classes may have a function called normalize, which then can trigger some actual steps, some processing that is done automatically always when you, for example, save this data in NOMAD. And this is really this function where you can now basically, if you are designing, for example, a schema plugin, and you have the power to define these schemas as Python code, now you can start imagining that you can put all kinds of things into this normalize function. As a kind of a dummy example, we have here a very simple normalize function that just says that, okay, if once we save this data, we can derive this population density by looking at the population and the area. So this is something that kind of gives you the idea of, for example, if somebody now fills in an ELN this population and the area, hopefully you don't have to like do this calculation manually and populate it as well, but the schema itself can do it automatically. So this is one use case for the normalize function, where it can basically automate this boring task that otherwise people who are filling this data in would have to do it on their own. But if we just like run these two fields, we can see that now if we fill in this country with a population and area, and we call this normalize function, we already get this population density in there automatically because of the normalize function. And now you can start imagining like there's all kinds of use cases for this. One example, as I mentioned, was this automatizing things for the ELN users, but this could be also about maybe if you fill in some file path, maybe the normalize function reads a file from this path and does all kinds of pre-processing to this data, and then puts the final results in some field in the schema. So, or it could be like a normalized function that retrieves some external data through an API call. This is really up to your imagination, and this really gives a lot of flexibility for the schema designers to automate things and basically make the life of the schema user like easier. So this is really what differentiates the YAML schema from the Python schema, is this normalized function. Essentially, what we've now looked at is that how do the schemas work? What is the difference between a Python schema and a YAML schema? And how you would basically, if you had to like manually fill these in, how you would do it. And now another very important part of the NOMAD infrastructure is parsers and parsing. So yeah, you don't always want to create these schema instances by hand. So not always do you want to fill them through an ELN or through them some Python code. Basically, parsing is the process of now, if you have a raw file and you want to transfer this into a certain schema, like we are doing, or like we want to do with these countries of the world data. So parsing is a basically there's parsers that can be associated with a certain file type, and they can automatically read this raw data and create a corresponding entry out of it that follows a specific schema as well. So this is really what parsing is in the nomenclature of NOMAD. And here we have an example of a very primitive parser that basically a parser basically has a parse function that takes in a main file. So this is the file from where we are reading the data from. It writes the things into an archive. So this is now basically an object that follows a certain schema, and you can also put a logger in there. In this demo, we're not going to use this logger at all, but basically the logger can be used to capture some parsing errors, for example, and report them to the user when the parsing is happening. And we can just like take a brief example of how like we started out with these countries of the world data, which is basically a raw text file which has these different fields in there. And how would we write a parser that actually goes through this data and writes it out into an entry? And this is what our parsing example is doing here. So we have a fairly simple parse code in here. So it takes in the main file, reads it line by line, and extracts certain things from it. This is not super important to understand what's happening in here. It just means that we are capturing this information in a Python dictionary. And now imagine we have this parse function. We can now read stuff from this dictionary and instantiate this country from there. So this is really what the parsers do and can do for you. So basically automating this entry creation from raw data. And this is what parsing is all about. And we can let's take a look at this parser in action. So this cell is basically going to call this parse function on a raw file. So we have this, you can notice that in the file hierarchy of this notebook, we have this raw data folder, which has these raw files that are basically these text files for each of these countries. So they contain this this data, which like contains a lot of different specific details about a country. So we have one for France, Germany, and Poland here, and we're gonna read the one for Germany. We're gonna parse it into this archive variable, and now let's look at what it looks like in JSON. So if you run this, you will see what it would look like as a JSON once it's been parsed. And you can see that basically we have this root section, which now has a data section where we have everything that we have defined in this country schema. So we defined that it should have a name and population. And if we also want to run the normalization that we defined, we have to do one more step. So we have to call the normal, we have to somehow trigger the normalize function. And this is typically done automatically by our processing pipeline. Just in this tutorial, we have to call it explicitly by calling this normalize all function. And after this, you will also see that the population density gets populated here as well. So this is basically gives you like some sort of an idea what parsers are in NOMA. So they take in some raw files in your uploads and convert them into entries, which themselves follow some schema. So this is like a very important thing to know. And if you had any problems in running this JSON, basically this when you are doing this, let me find the correct well, where do we use it for the first time? I think here. And remember that you had to run this first cell. If you haven't defined this or imported this JSON thing, you're going to get some errors. So remember to run this cell as well. After you have it enabled, you're going to be able to see this JSON structure in here. So that really covers, I think, the first part of this hands-on tutorial. Yeah, I think so. And then basically we're gonna go into this plugins a bit. We're not gonna go too deeply into the whole plugin world in this tutorial, but there's basically this link where you can learn much more about how you would do this by yourself. So there's a whole documentation page for this, but we're gonna look at the very basics of what a plugin is and then how you would define one in here. So basically, we already looked at how you would write a simple parse function to parse some raw files. And now, if you wanted to now make this into a plugin that someone else could install in their NOMAD Oasis, you would roughly do it like this. So there's as Marcus said, there's these GitHub kind of scaffold projects from which you can fork from, and they basically follow this kind of a fixed structure where you have first of all the code for doing the actual parsing. So there's some Python modules in your repository. You have an init.py, but then you have some additional files in there as well. So for example, there's a nomad plugin.yaml file, and in principle it can be something quite simple. It's a YAML file that describes the very basic things about your plugin. So first of all, what kind of plugin type is it? So in this case, we're looking at a parser plugin, and you can also say what's the parser plugin name. You can have a description in there. And in the case of parsers, this metadata file can also specify which main file should be triggered, or which main files should trigger this parser. So you can, for example, specify things like which kind of file names should trigger the parsing. Usually this is not enough just to have a file name, but you actually have to look at the file contents. So you can also, in addition, specify a contents regular expression that has to match before this file is processed by this parser. So it's these kind of things you can specify in the metadata file itself. And then you have, of course, the actual parsing code in there. And this is pretty much it. So this is what a plugin package is. It's typically a GitHub repository, which contains one Python package in there, which has some Python code, and then nomad plugin.yaml file that specifies this metadata. And that's in principle what a parser plugin can be in its simplest form. And now it's up to the Oasis users to activate these plugins. So an Oasis users has full control over which plugins are activated, and basically, like almost everything else, it's configured through this nomad.yaml file, which configures everything for your Oasis installation. So it also has a field for which parsers are activated in your Oasis, and it basically has something like a section for plugins and which ones to include and which are the available options. And this is how you would enable a specific parser or disable a specific parser in your Nomad installation. So
yeah, this is the process that we want to ease up with the registry, right? Eventually, when the registry is there, that you just say, okay, I want to enable this one, I want to disable this one, and
yeah, exactly. So currently you have to do a bit of manual labor. I think it's much better described here if you're really interested in doing this. But just to get an example of what, if you have a plugin registered, we can kind of mock this behavior in this notebook by adding this this configuration file into our notebook in here. So we're gonna basically run these few cells in here, and you will see that we basically get a few new files. So we have basically, we are writing this nomad.yaml file directly in this notebook, which says which plugins should be enabled in our kind of dummy Oasis installation that we run directly in the notebook environment. And basically, with this file in place, we can kind of run this parsing inside the notebook itself by basically importing this parse function from the Nomad client package. We can simply say now that, okay, I want to parse this raw file. And now we're not saying anything about which parser to use or how to do it in more details, but everything is handled by our processing infrastructure code that we already have. So once you have registered a parser, it basically reads in these metadata fields and knows which parsers will get triggered for this specific raw file.
it's important to note it's not just the nomad YAML that is now appeared, it's also the countries plugin directory there with the actual Python code in there, right? So if you open this one, this has the real, this is what it would look like when you develop this just in your, I don't know, Visual Studio Code or your PyCharm or whatever, right?
Exactly.
When you would do this outside the notebook, you would have exactly this structure. And then with the Nomad YAML in place, you can run basically all kinds of Nomad things. And when the Nomad library gets initiated, it reads this Nomad YAML file and basically then picks up the plugin and then knows about the parser and so on.
Yeah, exactly. And now you can see that we run it on this text or raw file. We actually get everything as before. We actually have even more functionality inside this plugin folder in here, which does more than what we defined before. You can see that it's actually also parsing the GDP and parsing all kinds of things from here. So that's like an example of how you would define a plugin and install it. And yeah, as I said, more details can be found in the documentation. But then I think what we want to now focus a bit more in this tutorial is that we're going to go into this basically how you would do analysis on existing data and how you would do plots and things like this. And this is basically going to be the topic of the rest of the tutorial. Let's briefly, I'm going to mention this this processing bit. It's not super important for this tutorial, but basically there's a whole documentation page now on how processing and by what is processing in Nomad and so on. It basically is this this whole act of parsing files, going through the normalization and putting them into all the databases that we basically have, persisting this data in hard disk and everything like this. And we basically want to kind of mock this behavior inside this notebook directly. And what we're going to do here is that we're going to basically create these archive files directly through this code field in here. So what we're going to do is that we're going to parse these raw files. We're going to write them as JSON files. And what we're going to do is that we're going to, because we cannot run this Python plugin directly from the notebook itself, we're gonna basically save this data as a JSON file and say that it follows a certain YAML schema definition. So we're gonna replace this Python schema reference with a YAML schema reference in order to get the processing going in this notebook. It's kind of
on the left side you already see the schema, right? The schema.archive YAML. This is basically our Python class, but now transformed into this YAML form.
Yeah, exactly. So it's not super important to understand what happens here, but it's you can think of it as a kind of a thing that we mock the processing with in this not.
That's the closest to what the actual NOMAD does that we can get to.
Yeah, exactly. But let's jump into the analysis part. So this is really about, okay, now if you have your data now inside an upload, what can you do with it? I'm giving some examples of this. And as the first cell here says that before any of these next cells will work, so you will have to have run this cell. But before proceeding, we should go back to our upload and reprocess it. And this is basically what it looks like. So we go back to this particular upload that we are working in. And in here, we have this reprocess button. And we're going to need to trigger this reprocessing for this upload in order for the system to kind of notice that we actually added these JSON files in here. It's just like a matter of, before we can do any analysis, we really need to have these entries registered into the system before we can do anything, do API calls on them. And so.
Basically, now we turn the files into entries, right? Before it was just files in your upload, and after the reprocessing, those really become NOMAD entries and they become available through the API and everything.
Yeah, exactly. And now if you want, you can actually also view this data directly in the GUI and see that they are kind of now, as Marcus said, transformed from just raw files into actual entries that have a bunch of metadata and all kinds of functionality that you can trigger on. Registered in the system, we can play around with our APIs a bit. So what we want to do here is that we want to now use our APIs to kind of fetch this data and do some analysis on it. So this is more like what you might do on your own computer to analyze some data that you have lying around in Nomad. So you basically contact our APIs to get the data and do some work with it. And we're gonna do this same thing in two different ways. So basically we can either use this very generic requests library, which is not Nomad specific at all. It's basically a Python library that is being used to just make REST API calls to any server, and we're just gonna use this library to do a post request into our Nomad client. So we basically can get these clients directly from here, this URL. So it's gonna just point to this staging installation, and we're gonna do a query we're gonna query the entries, and we get all of the authentication information automatically from this notebook, basically. So this takes care of this. And what the query that we're gonna do is that we're gonna query for things that have this main file and a certain upload name, and let's see what we get as a response. So the result will be written in here, and this basically shows you, we could maybe take a look at what it actually prints out. So it has actually found something, and this is the entry ID from this query result. So this would be a way of how you would request or interact with the data with this kind of non-nomad specific requests library to do some work with it. But we also allow a bit more like another abstraction layer upon this. So we have this archive query class that comes now from the nomad package itself. And it provides a few like conveniences compared to just doing just getting JSON data through this post requests. So for example, basically when you're using this archive query, all of the results that you get back are gonna be Python objects that follow the schema that you've been using. So it has like, it's not just JSON data, not just dictionaries and so on. It's really Python objects from the schema, and you can do all kinds of additional things on top. But this is how you would do the same or a similar query through this particular class. So once again, you need to write some sort of a query, but it already like knows all of the URLs. It knows the authentication is built in there, so you don't need to do that again. But here's for example, a query that says, I want to look at I want to get all the countries where the population is greater than this, so 50 million, I think. And basically, this is our query, and we also want the upload name to be this. And here we are saying which parts of the data we want to get. This required field means that we want to get everything under data in here. And this is basically now, once we trigger this download, we can get all of these countries in this variable. Let's just run this to download everything. And basically, this triggers the whole upload download procedure for this query, and gets everything. And you can see that we are now actually getting not just dictionaries, we are actually getting these actual entry archive objects which have this data section, and they will have other further subsections in them. So you can like more easily work with the schema and schema fields directly. So it's kind of up to you which way you want to prefer. So if you want to stick to something very generic, you could use this request library. But if you want to really utilize all of this pre-existing behavior, you could use this archive query as well.
Yeah, it seems a little bit superfluous for this super simple example, but if you're downloading 10,000 DFT calculations or whatever, then I would really recommend the archive query, which does lots of pagination and all kinds of things for you so that you don't need to do this stuff.
Yeah. And then like I would really recommend on reading more on these docs. You're gonna get much more details from our documentation about how you can use these different queries and what kind of things you can do with the archive query as well. Okay, I think with this we could maybe move on to doing something interesting now with these countries. So this is an example of, okay, now if we have the country data, let's do some plotting with them. And once again, like now it's completely up to you, because if you're in a this kind of a Python environment, you can use whatever plotting libraries you want to do this. In this case, we're using Plotly to do this, and pandas to work with the data a bit. So we're basically gonna get all of this data into a data frame. So we're gonna read the country, GDP, year. So remember that we basically have in our schema, we have this a country as a kind of a root section. It has a GDP subsection, and these subsections have a year quantity in there. So this is like a list of years basically, and we're gonna do this for all countries in this list that we just downloaded, and we're gonna basically plot this the GDP per year for all of these countries, I think in the same plot. So now if we run this,
and these country objects that you get from the archive query, these are basically instances of the Python classes that were written before, right? This is how the
exactly.
JDP year thing works, and then also the unit would be attached to it and all this kind of Pine stuff.
Yeah. So this is really like what you get if you use this archive query directly. You get all of these nice features, so you don't need to worry too much about unit transformations or what is the exact name. So you don't need to work with JSON structures, but these, as Marcus said, they're really like instances of the schema sections and so on.
And depending on the programming environment, you might even have co-completion and stuff like this.
Yes. Yeah, exactly. So now basically we have a plot for we said for all the countries with more than 50 million people in them. So in this case, it's France and Germany. Plotted here using Plotly. This basically now fetched all the data through the API from these entries, and it's like a nice example of what you could do with the API. We have another example which is kind of similar. So we now have the birth rate per year here as well, with a very similar syntax in here. It's just another example of what you could do in here. We could, for example, see that, okay, if we lower down this to 5 million, I think then we will probably fetch even Poland then here. So let's update this. So now we have Poland here as well. So yeah, you can do quite a lot with this APIs already. Here, let's do the same, run this as well. Okay, so, and then if you have any questions about the query syntax and things like this, just ask away in the chat. But this is like an example of what you could do with our APIs. Then it's up to your imagination.
Yeah, by the way, these more complicated things like using the API or writing the plugin metadata or how to develop plugins in general, these are all good things to discuss on the Discord, right? And building a community and hopefully getting some maybe some answers there. Yeah. So this is what we wanted to do with the Discord, but we also have a forum and these kind of things, but there will be lots of questions after the thing, I guess.
Yeah. I think one of the remaining things that I really wanted to highlight, or we want to highlight, is this. Okay, now we did some plotting by basically fetching the data through the API and doing the plotting in these notebooks, but we also have like a lot of support for defining plots directly when people view the entries in here in the GUI. So now when we view, for example, this data for Germany, we don't see any plots in here. We just have the raw data. So we will basically have all of the data in here about the GDP and birth rate. So the vectors are in here, but this is not super nice to read in, because you can't just turn them into plots in your head typically. So now we want to look at this use case where, okay, what if we want to see a plot here? How would we do this? So that we wouldn't always have to go through the API and do the plotting on in Python directly. So we're going to explore a few things that you can add directly in your schemas to create plots, basically. And the very first thing is, the very first example of this is to use this plot annotation. So we have this concept of annotations that you can add into your schemas. And basically, now we already had like an example of how you would define the data structure and all the descriptions and units and things like this in the schema. But through these annotations, you can kind of add this more advanced functionality, typically related to the GUI, so how the GUI like reads this data in, and this plot annotation is one of them. So you can, here we can see an example of what a plot annotation would look like in the YAML world. So you can see that we have to use this plot section. So we are inheriting our root section not only from entry data, but also from plot section. And now we can add this annotation saying that, okay, now I want to show a plot of the birth rate year as an axis and the birth rate value as y-axis. And we have some layout configuration here as well. So what is the title that we want to show in here? And this already like tells now our system that, okay, this is a plot that should be shown when this data is viewed. So this is one way of achieving this. And the same thing as a Python, in the Python equivalent is basically something like this. So you add this annotation as you added it in here for this basically this root section. You added the exact same things in here. So it's like an A underscore means that it's an annotation. It's a plotly graph object, exactly like we did here. The same values for X, Y, and layout. And you can see that we are inheriting from entry data and from plot section here as well. So it's very similar. And if we let's run this as well. And now with this done, if you run now basically this cell, you will also now be able to see the changes take effect in the NOMAD installation that we are in. So if we go back to our upload now, and let's reprocess it once more, because we have now like we have changed the YAML schema definition to include this plot annotation. So if we reprocess now these entries, and let's take a look at, for example, at France, we will now see the changes take effect. So this is the plot that we defined in the schema. So we wanted to have the birth rate year versus birth rate value, and here's the layout. From the layout, we get these titles. So this is like the simplest form of defining a plot for a schema that you're working with. And you could define multiple plots and plots for different sections and so on. So there's lots of options for this. If you want to learn more about this, I would once again like recommend looking at the documentation. So for this annotation, there's quite a lot of documentation already. So you can take a look at more examples there of how you would use this. And this will get you already quite far with plotting, but you can maybe at some point imagine that this becomes too limited for you. For example, you can only reference like entire like quantities from your data. You cannot, for example, mix data in here. For example, you cannot multiply values and things like this. So this is really good for fairly simple plots. And the benefit is that for these, you don't need a Python schema. So you can just do all of this with a YAML schema only. So it doesn't require your own Oasis. For example, you could do this in our current production deployment. For example, you can define a YAML schema that does all of this plotting for you automatically. But then if you need something really that goes much beyond this, then we'll need to do something else. And then this is what the last section is about. So this shows an example of if we want to do some much more complicated plots, fully customized things in here, we can do it through the Python schemas. And this is once again where the normalize function kicks in. And this is why the YAML schemas cannot do this. So we're basically programmatically defining the plot using, in this case, Plotly directly. So let's take a look at how this would work. So here we are basically saying once again that, okay, it's a plot section, so this hasn't changed, but we are no longer defining the plot in here as an annotation directly, but we are instead writing the plot directly down into this figures field, which it's basically inherited from the plot section, and it holds all these figures in there. And if in its essence, it's just a list of these graph objects basically, and that Plotly supports. So you can learn more about the graph objects through this link, but it's a JSON file, a piece of JSON that defines the plot and its layout and its data completely. So this really gives you the flexibility to do any kind of plotting that Plotly can do. So Plotly is this library that we are using here. And we can define our fully custom plot and just save it in this figures attribute, and we're basically done. But this gives you like an idea of what you could do if you, for example, wanted to do a very complicated plot that grabs things from different quantities, mix them together, maybe read some file and does some post-processing on it. So this would be the way to achieve it in these Python schemas is using this, using the power of the normalize function, basically. And once again, we can just run this field in here, and we can have a look at what sort of effect it has had on the data by going back to our upload. And if we once again now reprocess this, we will see our changes take effect. So let's once again view France. And now you can see that this plot has changed. Now we are instead, what did we want to plot? We are now plotting the GDP per year in here. So in a sense, the same thing could have been achieved with this annotation, but it like gives you an idea of like, now this no longer has to work with annotation limitations. We can do anything that basically Plotly can do in here. It could be all kinds of plots in here. But we see that the plot is now figured saved independently here. We can even see it in the data itself. So we saw that we basically added it directly into this figures list, and it's a piece of JSON data in here. It gets shown also in here. So this is how you would do like completely custom plots, and this is like maybe the most advanced example of plotting you could do. I would say that if you can go with the annotation, it's great, and this will already get you quite. But if you need to do something really complex, this would be the way to do it. So kind of I would say as a takeaway, always if you can do it with the YAML schemas, it's a good idea, I think. But when you encounter these more complicated use cases where you need really the power of this normalize function, then you need to write your schemas and plugins in the Python way, basically. I don't have anything else now officially. Do you have, Marcus, have anything to add?
Yeah, for those that don't really want to stay to the end because they don't have questions or whatever, thank you very much for participating. Also, now thanks again to the organization team and all the developers in the background and everybody who contributed to Nomad so far.